Example 1, Adult Sleep Confidence Interval Method. The author obtains times of sleep for randomly selected adult subjects included in the National Health and Nutritional Examination Study, and those times and hours are listed below. Here are the unrounded statistics for this sample. So we have our sample size, which is 12, the sample mean, 6.8333 hours, and a sample standard deviation of 1.9924094 hours. A common recommendation is that adults should sleep between 7 hours and 9 hours each night. Use the confidence interval method to test the claim that the mean amount of sleep for adults is less than 7 hours. So just so that we can do it, if we plug this into StatCrunch, we can do the following. So we can go ahead and then highlight our column and put in sleep hours and then enter in the hours. And then if we want to confirm our mean and our standard deviation and our sample size, we just go ahead and go to Stat, Summary Stats, select Columns, select the column that we create, which is sleep hours, and then select the sample size, the mean, and the standard deviation. And then select Compute, and then you're going to see that we get the same numbers here as we got up here. Okay, now recall with the confidence interval method. Okay, because a confidence interval estimate of a population parameter contains the likely values of that parameter, you reject the claim that the population parameter has a value that is not included in the confidence interval. And then here are the confidence level for the confidence intervals. So let's take a look at step 1. The claim that the mean amount of sleep for adults is less than 7 hours. So it is a left-tailed test with a significance level of alpha is equal to 0.05. So if it's a left-tailed test, that means it's a one-tailed test. We know the significance level is 0.05. And so therefore, if it's a one-tailed test, then we're using the 90% as the confidence level. So the next thing we want to do now is to find the margin of error that corresponds to 90% confidence interval. So we want to first find the critical value for the significance level of 0.05. So we first need to take our degrees of freedom, which is 12 minus 1, which gives us 11. And then we're going to take alpha. We're going to take 1 and subtract 0.90, which gives us 0.10. And then alpha divided by 2 is equal to 0.10 divided by 2, which is equal to 0.05. So therefore, what we're going to do now is then find that critical value. So if we do that, we can do that by using StatCrunch to get this value here. If we go to Stat, Calculators, and then we're going to go to T, since it's a T distribution, and we're going to put in our degrees of freedom of 11. We're going to select greater than or equal to because we want the critical value that's positive here. So we're going to put in 0.05, and then we get 1.796 for our critical value. Okay, now that we have our critical value, now we can find the margin of error by the following. So we have our critical value, we have our sample size, and we have the sample standard deviation. And recall that the formula for the margin of error is equal to the t critical value times the sample standard deviation over the square root of the sample size. So we found the critical value to be 1.96. And then we're going to multiply it by the sample standard deviation of 1.992404984. And then we're going to then divide that by the square root of the sample size, which is 12. Let's go ahead and do this on our calculator. So what we're going to do is we're going to take parentheses 1.796, and then we're going to multiply it by the sample standard deviation of 1.992404984, and then put the parentheses there and then press enter. And then we're going to divide that by the second square root of 12. And so then we get, rounded to 6 decimal places, we get 1.032983. So that represents the margin of error. Now what we want to be able to do is find the 90% confidence interval estimate of the population mean. So constructing the confidence interval is easy now that we know that the sample mean is 6.83333333, and we have the margin of error that we just found in step 2. So recall that that's the sample mean minus the margin of error on the left side, the sample mean plus the margin of error on the right side. So let's go ahead and do that. So we have our margin of error and we have our sample mean. So there's our sample mean. So we know we have 6.83333 on that side and the same thing on this side. And then we're going to subtract the margin of error on the left side and add the margin of error on that side. So we end up getting 5.800350 for the lower limit, 7.866316 as the upper limit. And we're going to round the 2 decimal places. So if we round the 2 decimal places, we get 5.80 hours on the left and 7.87 hours on the right. Now in step 4, in testing the claim that the mean is less than 7 hours, we use the null, where the null is equal to 7 hours. But the assumed value of the mean is equal to 7 hours is contained. It's actually in this confidence interval limits. So therefore, the confidence interval is telling us that 7 hours could be the value of the mean or the population mean. So we don't have sufficient evidence to reject the null, where the null is equal to 7 hours. So we fail to reject this null hypothesis, and we get the same conclusions as we did for the hypothesis with the p-value method or the critical value method.